All right, what we're talking about today is something called valence electrons. It's something that's very important in chemistry because the number of valence electrons an atom has is generally what determines how it's going to react with other chemicals. So before we talk about valence electrons, I just want to go over a quick review of atomic structure in general. We talked about last week the history of it and how different scientists discovered these different parts of the atom, but I just want to go over it one more time and make sure that you guys have a general idea of it. All right, so the middle part here in the center, this is what's called the nucleus. All right, this is where like 99.999, whole bunch of nines, percent of the mass of an atom comes from. It's all condensed into this very compact area right in the middle where the protons and the neutrons both are. So protons are the positively charged particles, and the number of protons in an atom is what determines what element it is. All right, so every single lithium atom is always going to have 3 protons. If it has 4 protons, it's no longer lithium, it's a different element. All right, and neutrons are the neutral particles. They don't have a charge to them. They have about the same mass as a proton, and they also are in the nucleus. The number of neutrons can change without changing the element, and the elements of the same type with different numbers of neutrons are called isotopes. So we kind of touched on all that last week. Just wanted to review it one more time. The electrons orbit around the nucleus, and they are, it's not shown correctly in this picture, but they are very, very, very small compared to the protons. They're like so small that when we're talking about atomic mass and the weight of each atom, we don't even count the electrons into it. They don't matter, no matter how many of them there are. It's all about protons and neutrons when it's talking about the mass of an atom. What the electrons are important for is their charge. So electrons have a negative charge, all right? And in a neutral atom, which is what the natural state of an atom is, you will have the same number of electrons as you do protons. Okay, so they balance each other out. All right. So the term we mentioned earlier was valence electrons, which is a special type of electron. And what it is the electrons that are in the outermost orbital of any given atom. So like this one, these two on the inner orbital here, we wouldn't call them valence electrons because it has ones on this next orbital. All 6 of them on this outer orbital are the valence electrons. All right, and that's what we're talking about today. So, like we just said, valence electrons are the electrons in the outermost orbital of an atom. The number of valence electrons in an atom kind of determines how it's going to react with other atoms. So all the elements in the same group on the periodic table, so that's the columns, the vertical rows, everything in one column is going to have the same number of valence electrons. So that column on the far left, like it was talking about in the periodic table video we watched last week, the alkali metals column, those all have 1 valence electron, so they all react pretty much the same way. They all react with water and with other elements pretty violently. Okay? So you can see here, so all the ones in this far left row, these would all have 1 valence electron. The next row over, all these ones, they have 2 valence electrons. All right, that means there's 2 in that outer shell. In the middle, things get a little funky, where these guys can have different numbers of valence electrons depending on how they're being ionized. But once we get back over to the right, things start to make a little more sense again. So this middle section, a lot of times, we're going to just ignore it for this purpose for now. All right, so the first column, 1 valence electron. Second column here, 2 valence electrons. We skip this middle bit. Everything in this column, the 13th column, it has 3 valence electrons. The next column over has 4, 5, 6, 7, and then this column has 8 valence electrons. It has a full outer shell. All right. And so like I talked about, the number of valence electrons determining how these elements are going to react with other stuff. The ones over here that only have 1, they really want to get rid of that 1 electron so they can go down to having just the 1 shell below it being full. Atoms with a full outer shell don't want to react, and that's what all the atoms kind of want to get to. They want to get to that stable state. So these ones here on the far left, they'll do pretty much anything to get rid of their 1 valence electron and give it away. So they'll react with anything. Same goes for these guys here. They're really easy to react with because they just want to get rid of their 2 valence electrons. These next couple rows, the ones with 3, 4, 5 valence electrons, it's a little trickier for them, right? It's harder to find willing acceptors of things that want to take all 3 of your valence electrons. So they don't react quite as often or quite as violently. But then you get over to the oxygen and fluorine rows, and these guys have 6 valence electrons, which means to fill up their outer shell, they need to get 2 more. So they really want to react and grab 2 extra electrons. Same with these guys here. They need 1 more because they have 7 and they want to get up to 8, which would be their full shell. So they'll take an electron off of anyone and just rip it away. All right, and then the far right row, these are called the noble gases. They have full outer shells. They're good. They don't react with anything. They do their own thing. Okay, so you can see how the way the periodic table is arranged and the number of valence electrons an atom has affects its behavior. All right, and so with that being such an important thing, the number of valence electrons something has, it's important to know how to figure that out if you don't have a periodic table handy, or if you need to do it for yourself if you're not sure which row is which or whatever. So the way we're going to do it in here, for now at least, is by using Bohr models. If you remember, we talked about the history of atomic structure. Schrödinger eventually came along and replaced the Bohr model with his quantum theory. And while it is more accurate, it's also way more complicated. And so for our uses, Bohr models are going to do just fine for the majority of the atoms we're going to talk about. So when we are filling up a Bohr model, remember, like I said earlier, that a neutral atom is going to have the same number of total electrons as its atomic number. So same number of electrons as it has protons. All right, and when we start to fill it up, you're always going to fill in the inner shells first and fill the inner shells up completely before you jump out to the next shell. So your first shell can only ever hold 2 electrons. So if you've got more than 2, you put 2 in and then you move out to the next shell. The next shell holds a max of 8 electrons. So 2 in the first shell, 8 in the second one. And then the third shell can also hold a max of 8 electrons. Anything over that, things start getting funky because the fourth shell holds 18 electrons, and then you get all kinds of mixed up problems with those elements here in the middle, the transition ones. So we're going to only focus on things that can be done with 3 shells for now. All right, so for an example, if I told you to draw me a Bohr model of sulfur and then tell me how many valence electrons it has, so how many electrons are in the outer shell. First thing you do is go to the periodic table and find sulfur so that you can figure out its atomic number. So the atomic number of sulfur is 16. All right, that means it has 16 protons. So in the nucleus in the middle, you're going to put 16 protons. And then for the number of neutrons, we're just going to use the most common isotope, which would be the whole number that's closest to the atomic mass that shows on the periodic table. So if the atomic mass is 32, and we have 16 protons, you've got to subtract the 2 to find out how many neutrons there are. So 32 minus 16, that means you have 16 neutrons. All right. Then we start filling up our orbitals. So we're going to put in our electrons one at a time. And like I said, you've got to fill in the inner shells first. So this first shell can hold 2 electrons max. So we'll put one there and then one down there. All right, and when I do this, I like to draw them in the other shells in pairs, just because it helps me keep track of them, makes them easier to count, but you can do it however you want. All right, so now that this inner shell is filled up, it's got its 2, it's all full, we can move to the second shell. And we said the second shell can hold 8 total. So we're going to go one there, one down here, one over here, one over here, and then start making pairs. One there, one there, one there, and one there. So now we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total electrons. We need 16 in total, so we move out to our next shell once this second one is all full of 8. So we're going to put one there. That's 11, 12, 13, 14, 15, 16, and then we stop because we've got our 16 total electrons. All right, so this would be your Bohr model, and if I asked you how many valence electrons it had, you would go and count the outer ring. 1, 2, 3, 4, 5, 6 total electrons. Sorry, 6 valence electrons. Okay, and if we go all the way back and look at our periodic table, it is in this column here where it should have 6 valence electrons. So we did it right. All right, let's go back through adding all these in. Okay, another thing that we can talk about is ions. So ions are atoms with a charge. We talked about neutral atoms having the same number of protons and electrons. Ions have a different number of protons and electrons. Right? Negatively charged ions are called anions, and they have extra electrons. They have more electrons than protons because the electrons have negative charges. Positively charged ions are called cations, and they are ones that have given away electrons, so they are missing electrons. They have fewer electrons than they do protons. And the way that I remember that, it's kind of cheesy, but anions sounds like onions, and onions make you cry, so that's a negative thing, right? So that is negatively charged ions are anions. You can remember it however you want, but that's what works for me. All right, so here, if we're going to do a model of an ion, so this is how they're written. It's the atomic symbol from the periodic table, and then the charge in a small number, a superscript to the top of it. So an F1 ion is a fluorine ion with a charge of -1. If we said that negative ions have extra electrons, if it has a charge of -1, that means it has 1 extra electron. So here, in the nucleus of a fluorine atom, you would have 9 protons, because that's its atomic number. That never changes, all right? If it says 9 here on the element, that's how many protons you have. And then the neutrons, this is closest to 19, so we would say 19 minus 9 gives us 10 neutrons. Okay, so that's our nucleus. And then for our electrons, if the regular neutral atom would have the same number of electrons and protons, it would have 9 electrons. And our ion, we have 1 extra electron because it's a -1 charge. So we're going to have a total of 10 electrons. So we'll start putting those in. 1, 2. Remember, we got to fill in this inner shell first. And with 2 electrons, it's full. And then we can move on to the next shell. So then 1, 2, 3, 4, 5, 6, 7, 8 in the outer shell gives us a total of 10 electrons. All right. So we have one more electron than we do protons, which gives us that -1 charge. Okay, so you guys are going to do an assignment where you're going through and determining how many valence electrons are in certain atoms and ions. And that'll be your homework for this unit. All right.